Hey everyone, welcome back. So today we are diving into the classic Edexcel S1 massive 14 marks on the statistical model correlation and regression question. So it looks scary, but we'll break down into bit-sized pieces of these questions, okay? And then we'll start solving this question. Okay, all right. So first, let us understand and read the question. So reading the question is the top priority. Okay. So first, so you can look at this given question. So a statistical model are cheap and quick way to make prediction about a real world situation. Give one reason why statistical models are used. Okay, so this question. So first, directly we'll try to answer this part A, and then we'll read the part B for questions. Okay, so why we need to why we need a statistical model? So to improve the understanding to improve the understanding of statistical, okay, so statistical data in a real world. So this will be the answer for the part A. So it's a very easy question. Okay, so let's look it into the actual question. So what the question is talking about. So here, Madison wants to develop a model to describe the relation between the average daily temperature and the household daily gas consumption dm cube in winter session. So basically in winter session in UK, Madison wants to describe a model, a statistical model. So you're using regression and correlation concept. So he was actually doing a data based on average daily temperature and the daily gas consumption. So in winter, so Madison takes random. So here Madison takes a random sample for 12 days, okay, in winter and quotes daily gas consumption. So which he got it, that is W is equivalent to 11.6. So if you look at this data, W is equal to 11.6, that is the gas consumption in winter, which is 11.5. D, okay, so D is here a gas consumption. Okay, so now let us directly look into the question. So what are given here? Okay, so let me take you to the next page. So I have just taken the part B. We will solve the part B. So first we will write down what are the given datas. All right. So here what is given? So STT. Okay, so STT is given. So even if you don't know what is STT, so just you can understand that when solving the question. So STT is given. How much STT is 26.43 and STW is a negative 91.55 and sigma W is 339.25 and sigma T is the total average temperature is 9.1 and then sigma W square in winter session. So these are the data which already given by the examiner. Now, so we need to show that SWW is equivalent to 445.57 to 2 decimal places. Okay. Well, all right. So while solving this question, so it's very important that we need to know the first equation. So here on the right side, you can see SXX is equivalent to what is the equation. So this is the equation I have taken from the equation sheet. So you will be provided an equation sheet in the Pearson Edexcel exam. So you have to take those data and then you have to you have to use this equation sheet. So first I'm going to I have already marked the equation sheet. Equation that is SXX is equivalent to what is the equation. So don't look at this part. Okay, so you can only look at the part which is in the yellow color. Okay, yellow highlighter you can see, right? So from this I have taken the data. Okay, so that is SXX is what? Xi whole square and summation of x square upon n. So from the same, it is similarly here it is what our equation is SWW. That's it. Okay, so here SXX, so here it is SWW. So there is only the variable is different here. So SWW is equivalent to Or what is SWW in that case? Here it is X. So here only the variable is W. So in this case, I can write sigma of W square minus sigma of W whole square upon N. So here the N value is 12 days. Okay, so N value is given to be 12 days because the number of days. Okay, so he took the sample is 12. So I think you got it, the data. Okay, so from here, so we got that the data is what is our sigma of W square from here. So we can write down this is our sigma of W square. So that will be 10,036.45 minus. So what will be our sigma of W? So this will be our sigma of W, that will be 339.25 whole square upon N value is 12. So let's plug these value in the calculator. Yep. So here is our calculator. So let's plug this value in our calculator. Let me plug this value in calculator. So which is going to be 1. I want you to also start do along with me. Take a book, your pen and paper. Yep. So 1,036.45 minus, open the bracket. So 339.4525, close the bracket, whole square divided by 12. So that will give you 445.57 due to significant figure. So this will be the answer for our part B. I hope it is very clear. So now let's move on to the part C. Okay, so for part C here, what does the question is talking about? So find the value of STD and SDD. Okay, so if you could not see it well, it is STD and SDD. So let's find out STD. Okay, so again, you have to look at the equation sheet. The formula number is going to be number 3. Yes. So here the formula is number 3. So that will be STD. Okay, so what will be the equation in this case? So okay, so STD and STW. Okay, so first, so we have to find STD and also we need to calculate SDD. All right. So from this, we have SXY is equivalent to what? Sigma of X y minus sigma of X, sigma of Y upon N. Similarly, so I don't have a direct relation for STD here. If you look at this question, so here I don't have any relation for S and T directly, but I have another relation which is about W and D. So we can see W is equal to 11.5 upon over D. So from this we can say that what is D is equivalent to W upon 11.5. Okay, so remember, so we don't have direct relation for T and D, temperature and daily consumption, but we have the relation which is STW. Okay, so STW is given, so we will use this D wherever D is there, we will put that value as W by 11.5. So, okay, let's see how we are going to do that. All right. So here, what is STW? So that will be sigma of TW minus sigma of T, sigma of W upon N. So now we got this equation, right? So similarly, we will make in the place of W, okay, so in the place of STD, okay, so for STD also what will be our equation for STD? So similarly, if you write down the same equation, so STD will be sigma of T D minus sigma of T sigma of D upon N. All right, now coming to the actual question. So what is our sigma of TD? We don't know, right? So but we know our D value. So from given equation, W is equal to 11.5 D, and then D is equal to W upon 11.5. So now we will write down in the place of wherever we see D, we will write down W upon 11.5. Okay, so only I'm replacing the value of a D, which is W upon 11.5. So now sigma of T, I'll write it as it is, and then sigma of D, I can write it as sigma of W upon 11.5 N. So now here I can take common 11.5. Okay, so 11 okay, so 11.5 I can take common. So what will be the remaining? Sigma of T W minus sigma of T into sigma of W upon N, right? So this I can replace with this yellow box. Can you see exactly? Okay, so it is same, right? So now I can write in the place of sigma of TW, right? So in place of sigma of TW, I'll write down that 1 upon 11.5 multiplied with sigma of TW is equal to 11.5, right? So I know already this value is going to be what from the question is TW. It is here minus 91.55, right? So which will be further equivalent to what is minus 91.55 divided by 11.55. So which is given to be okay, so if I will use calculator to solve this, minus 7.961. Okay, so and then I'll round it off to three significant figure. So with this is going to be a three significant figure. All right. So I hope you have understood this question, part C. And then also we have to do there is SDD. Okay. So to calculate SDD, so we have a variance relation. So we have our variance of W, which is equivalent to 11.5 square variance of D, right? So similarly, we can write down that is SWW is equivalent to 11.5 square and SDD. So then we can say that SDD will be equivalent to SWW upon 11.5 whole square. All right. So is this step clear? So now we know that what is SWW. SWW, which can be already in the B part. Okay, B part, our answer what? From B part, SWW is 445.57. So which is going to be 445.57 divided by 11.5 whole square. So this, if you calculate using simple calculations, I'm not going to show it in the calculator. So this is going to be our answer, that is 3.369. So this will be our answer for the part C under that second part, which is SDD. So part, if you look at the part A, so under this will be negative 7.961 will be the answer for C question part 1, and then our answer for the next part will be 3.369. Okay, all right, I hope it is very clear. Next our part would be D part. Okay, so to calculate D, so we need to know the equation. So first let us read the question, read and understand the question. So what is our, find the product, okay, so find the product moment correlation coefficient between D and T. Okay, so find the product moment correlation coefficient. So we have our directly from the equation sheet. If you look at it, yes, so this is the equation sheet. If you need to look at it for this particular question. Yes, so this is the product moment correlation coefficients. So what is the equation? So let us copy down the equation from the equation sheet. So R S S Y upon square root of S X X SYY. Okay, so for this particular question, the answer would be okay. Okay, so here we have D and T, right? So the relation would be, so similarly here for this particular question, it would be STD upon square root of STT. Okay, so it's a suffix, okay, STT multiplied with SDD, which is equivalent to, so what is our STD value from the previous question? So that will be from the previous part here, it was 7 point. Okay, so negative 7 point. Okay, so you need to look at the previous. Okay, so this answer was we got our STD. The answer for that part is minus 7.961, and SDD we got our answer to be 3.369. Okay, so okay, STD value we are going to put 961 upon square root of STT, so which is already given 26.43 multiplied with what is our SDD value, which is 3.369, which is going to be further. So our R value is going to be, if I will calculate it using the calculator, 0.849. Okay, so this will be our value for R. So the answer for R part D is going to be 0.849. Okay, so you can use the calculator for the relevant answer. Okay, so since it's a simple calculation, I'm not showing with the calculator. All right, so let's move on to the next part E. Okay, so part E, so let us first read the question for part E. So here, given an interpretation in context of your product moment correlation coefficients. So already, so we obtained background illa, very nice math. Okay, all right. So given interpretation in context of your product moment correlation, which is going to be, let's say, so we already got our answer for R in the part D. What is our answer for part D? Minus 0.849, right? So this is our answer for part D. Okay, so we got our answer is a negative 0.846, right? So we have to use this value to interpret in context of your product moment correlation. So for that, so from the statistics chapter, if you're learning, right, so you will get the data from the statistics, which is going to be this is what our data is. All right. Yes. So here I have made a step by step for range. Okay, so if this is the range, okay, so what is our correlation here? It is going to be linear relation. All right. So look at this table. So this table is going to be helpful for you to answer this question. Yep. So here its range is what? Minus 1 to 1. So we got our answer less than 1, right? So less than 1, what is the correlation here? Strong correlation. So we can answer this question to be what? Okay, part E answer to be, you can look at this data, right? So this is plus or minus 0.7 to 1, plus or minus 1. So our answer is in this range. So that is 0.7 minus 0.7 to plus 1, right? So the answer, this number will be lying in between minus 8, 0.849 will be in the range, right? So therefore we can say it is a strong correlation. If it is in this range 0.5 to 7, so it will be in the range of moderate correlation. So if you have a 0.3 to 0.5, that will be a weak correlation, and then very weak correlation. So you need to know these statistical data from your equation sheet. You'll get it. All right. So this I have made it for you, so you can easily use this. Okay. All right. So we got that it is minus 8.49. So it is not with the negatives. It is all about the data. Okay. So that is interpretation guide. So that is, we can say that this will be what? Good So we can say strong, good negative. Okay, so good negative correlation. Good negative correlation. Okay, good negative correlation, which means, okay, so what is the meaning of that? Okay, so means that the households, households, okay, households gas consumption. Okay, so gas consumptions is, okay, gas consumption is linear. Okay, so since you can see linear relations are linear when the average daily temperature, okay, daily temperature increases. Daily temperature increases. This is the answer for our part E. Okay, so this is a simple question, but anyway, so still you will get 3 mark for this question. Yep. Our next question. Okay, so I hope part E is understood. So if you wanted to take screenshot, you just pause the video and take the screenshot. Okay. All right. So our next is part F. So first, let us understand the question of part F. So part F shows that the equation, okay, we need to show that the equation of the regression line of W on T is W is equal to minus 3.46 T plus 30.9, where the values of the intercept and the gradient are given to 3 significant figures. So here we need to find out the gradient. So this is minus 3.46 is the gradient and this is the intercept. Okay, so here if you compare this equation with the y is equal to mx plus c, so our m value will be negative 3.4 and our at c value, the constant will be, that will be our intercept. So that is 30.9. So we need to show that to 3 significant figures. That you have to keep it in mind. Otherwise, your answer would go wrong. Okay. All right, so first, how we will look at this. Okay, so here the given data, you can look at this. That is sigma of W, which is given to be how much? 339.25, right? So if I write this as W bar, so this is going to be divided. Okay, so we know that this is equivalent to sigma of, okay, so this is going to be equivalent to W bar upon N, right? So W bar, which is equivalent to 339.25 upon N. Okay, so how we will know that? Okay, so we know that um, W bar. Okay, so if you don't know the equation, right? So let me erase this and make it very clear. Okay, yes. So we know that sigma, okay, so that is sigma of W is equal to W bar N. So if you take W bar, which is equal to sigma W upon N, so that is how I got it. So sigma of W, which is given in the equation, which is already we know from here, that is sigma of W. And then what is our N value, which is 12, that is 12 days. So we will have to calculate sigma of W, which is going to be 28.027. Yep. Okay, so this will be our value for W bar. And then also we need to calculate T bar. Yeah. So sigma of T is given as 9.1, and we will calculate similarly T bar would be equivalent to sigma of T upon N, which is going to be what is sigma of T, which is 9.1 upon N is 12, which is going to be 0.7833. So this is the value of our T bar. Now, so we need to find the gradient. For the gradient in the equation sheet, there is an equation. for the gradient. So we need to pick up that equation. So I think if you are using the equation sheet, all right, so I can show you that from the equation sheet directly from the Pearson website. Okay, so this will be our Pearson equation sheet, and then if you look at this is the equation. Okay, so for our B gradient, okay, so the regression coefficient of the gradient will be this equation SYY upon SXX. So now we will come back to the yes board. So I'll write it down that equation since I didn't copy down. Maybe I will while editing I'll put it down that equation back to you. Okay. So now we need to calculate B. Okay, so which is gradient from the equation sheet. If you can pause and get it, so B value. Okay, so all the equations are on the same page. So B is equivalent to SEW upon STT. So what is our STW? So we already calculated from the previous question. In this question, okay, so already STW is given minus 91.55 upon what is our STT will be 26.43. So 26.43. So that will be our value of B, which is going to be negative 3.4642. So we will put it to 3 significant figure, 3 minus 3.46. So this will be our value of B. So value of A would be, again, that would be intercept. So we call it to find the intercept. So that would be intercept W bar. Okay, A will be equivalent to W bar minus B E bar. So what is W bar? Already we know that is going to be 28.027 minus B would be, okay, so B value is already, yeah, we calculated on the above, that is minus 3.46, right? And what is T bar value? 0.7833. Yep. So this is our T bar value. So now we will calculate our A value. So A value we got it 30.9. Yep. So 30.9 we got it, right? So and then we will have to put all these values back into the given equation. So which is the main equation. Yes. So that will be our B value, right? So here that will be, we got our B value, which is minus 3.46 T plus 30.9. So this will be our answer for F part. Okay. Our next part of the question will be our G part. Okay. So here in G, so what we have to do for G? Okay. So part G. Okay. So for part G, we have to write down that. Yeah. So for part G, W is equal to 11.5 D. Okay. So we have to find, okay, write down the regression of the line D on T, right? So we don't have a direct relation for D on T. So, but we know W is equal to 11.5 D. And also from the previous part, like all the questions will be interlinked. So D and F and G. So here we will write in the place of W, what I'll write, minus 3.46 T plus 30.9, which is equal to 11.5 D. So we need to calculate D. So therefore, divide everything with 11.5. So in this case, D will be equivalent to, we have to write D on T, not T on D. So D on T. So therefore, D is a subject. So D is going to be minus 3.46 divided by 11.5 plus 30. Okay, so T 30.9 divided by 11.5. So that would be equivalent to, if you divide with the calculator, so which already I have done. So 0.3008 T plus this would be 2.6869 and then if you round it off to three significant big figure, because they are asking our answer to be three significant digit, that is going to be minus 0.301 plus 2.69. This would be our answer to three significant figure for part G. So this will be the answer for part G. So I hope it is very clear. So we need to use the value W is equal to 11.5D for the value of G. Okay, so I hope once you get into the question, right, so the question automatically will make you to understand everything. Next part. So using your equation in part G, okay, so we have to estimate the daily gas consumption in the winter when the temperature is 2 degrees Celsius. So in the previous section, so we can um, take out the value of G. Okay, so what is the equation for G? We got it. So here there is a T. Okay, yes. So we will use the value of G. So we have to take this equation. So it is going to be, this is our equation with the three significant figure. Our equation would be, I have marked in the white box, you can see this is our equation. So this equation we are going to take and then put it in the next. They are saying using the equation in the part G, right? So we need to use the part G. So from the G, what is our G answer? Okay, so we'll take the answer of G. So what is our answer of G? D is equal to is equivalent to 0 point minus 0.301 T plus 2.69, right? So that was our value of um, G. Okay. So and then now here we have to plug the value of T is how much. So when T is 2 degrees Celsius, what will be our daily gas consumption? So it's very simple. So just we have to substitute, that's it. So minus 0.301 in the place of T, I'm going to plug 2 and then 2.69. So now you have to use the calculator, and if you calculate it, so that is close to 2.088. So if you round it off to the three significant figure, 2.09, so which is to three significant figures. Okay, so I think you have obtained the answer for part H, first part. Okay, so here part H, we have a second part which is going to be, so here interpret the effect and increase. Okay, so here we need to interpret the effect on an increase of 1 degree Celsius in average daily temperature is expected to have on daily gas consumption in the winter. So we need to interpret. Okay, so interpret the result. So what is going to be our daily gas consumption? Okay, so now, so this means that basically here we have to talk about the gradient. So what is our gradient? The gradient what we have obtained, which is going to be minus 0.301, right? So minus 0.301. So this means that, okay, so what does this means? So they are talking very clearly. It says interpret the effect on an increase in 1 degree average daily temperature is expected on daily gas consumption. So we obtained a daily gas consumption equation minus 0. So for this, the intercept was this. So definitely we have to take this temperature related, right? So that is why I took this value. Okay, so you might have, okay, why you have taken this intercept? So this is our daily gas consumption from the previous equation I took, that is minus 0.301 T. So this means that, okay, for 1 degree, right? So for 1 degree increase in average daily temperature, which means that when the temperature, right, the daily gas consumption, the daily gas consumption is expected to decrease by 0.301 meter cube. So this will be our answer for part H, second part. All right. So I hope you have understood all the part of your questions very well. So that's it for question number 3. Thank you.